Hi, today we are going to take a look at some particular items used in missiles and drones. So the first one is this small item, which is actually the GPS module of the Granat 4 Russian drone. There is here a GPS ceramic patch antenna. So we have here the active area. It is connected to this PCB board using this pin here. On the bottom side there is a ground plane. On that PCB you can see a CAN, so this is an amplifier. The output and the power supply of this amplifier corresponds to this coaxial cable, which is connected to a second board here, which is a GPS module. It is maybe possible to remove the cover here. It seems soldered on several points. Let me see. Okay, I will try to remove this cover. We can see that we have several ICs. The two parts on the bottom side are actually standard GPS receivers. You can see a resume of the datasheet here. On the top here there is a CPU section. Here we have a flash memory. And we have another part here. This part is maybe an FPGA. And here there is probably a microcontroller. As you can see, this part is actually a DSP. More precisely, an ADSP from Analog Devices. The second item here is more interesting. This is the CRPA of the famous Shahed 136. This model is supposed to be an Iranian model. This is a pattern of 4 antennas. It is an anti-jamming and anti-spoofing system. 4 antennas permit to limit the cost and also the size of this system, but you can find the same thing with 7, 9 or even 16 antennas. We can see the patch antenna. So it is more or less the same thing. We have the patch antenna and we should have a small amplifier on the bottom side of this PCB. And we have here 4 coaxial cables. The antennas are connected here. This one was manufactured in 2024. You can buy something like that on eBay for a price of between 300 and 400 euros, so very expensive. In Ukraine you can buy that thing for 1 kilogram of potatoes. So let's see what is inside. Okay, so we can see here an aluminium piece. This permits to transfer the heat of this part, which is probably an FPGA, to the cover. Inside there is a PCB. So here we have 2 identical parts from Analog Devices, AD9361. This part is actually an RF Agile transceiver. It's a very nice design with tiny resistors, a 201 package and a 402 also. Some parts are not populated. Next item is a thermal camera from a Russian drone. We can see on the bottom side 2 servo motors. You can see the copper adhesive for shielding. The thing can move in all directions. We can see here an optical encoder from US Digital. We can see the very fine pitch of this encoder. And on that side there is a PCB. There is here a microcontroller, an STM32, and there is another programmable part here. It seems to be another STM32. Do you want to see what is inside this box? This is a potted module. I think that we have accelerometers and rate gyros. It is maybe used for the stabilization of the optics. I am saying that because of these two PCBs here, orthogonally placed. We can see here the IMU of a Nike Hercules missile. This missile was developed in the 50s. We can see here 3 rate gyros, one for each axis, a pitch, a yaw, and roll. We have here 2 accelerometers, one for the pitch, second one for the yaw. Here we have a pressure sensor. The manufacturer is Western Electric. There is here a plate with some passive parts, a few resistors and 2 capacitors. Here you have a displacement gyro. This thing is quite large. You can see the gold plating. Here we have 2 relays and 1 capacitor. The last item for today is this thing is a Nigla Manpads missile seeker. It is not complete, of course, but it is not in very bad condition. This thing can be orientated using coils. And we can see here several current sense resistors. They are probably in series with the coils in order to drive the coils using a current. This is probably a feedback. This thing is sensitive to infrared using 2 different sensors. One sensor is cooled So we can see this tube here. This tube permits to introduce pressurized nitrogen. We can see the entrance of the gas here. On the electronic side, we can see some hybrid circuits. There is one here, at least one on each board. You can see also the tiny resistors. For the moment, I don't want to do a teardown of that thing. I will try to do the reverse engineering for myself, and I will see if it is possible to orientate this thing, or if we can understand something. You can see the connection between the boards. So the best solution is to cut these wires and to place new wires after. That's all for today. Thank you for watching and see you next time for another video. Bye bye.